cool. All right, well, no problem. William, if you need to like ask a question and you're not able to, you can always do it in the chat, or you can do it in the after hours channel. That works too. Okay, rad. Okay, guys, so this is the basic project. I've added just a little tiny bit to it, but I want to first walk you through this project because there are a number of reasons why I don't like this project particularly, but I think there's a lot of good code in here that you can go back and reference later. Not necessarily the entirety of it. I don't know if you're going to build a NASA Mars rover fetching app again in your life, and I hope that you do something that's more of an interest to you. But there's a lot of awesome code in here, and I think it's worth pointing out a couple of things. So I did send out a message today that there are a lot of files that you guys won't need to mess with, but I wanted to point them out so that you can see what they do. So these are the different structs that are involved. And basically what Andrew has done is he's just communicated with the API to figure out what certain like values things need. So this photo reference refers to the exact photo that is involved with the Mars rover. And then the Mars rover is the actual like robot that lives on the planet and takes the photos, roams around. The sol, so like a sol is a full solar day cycle. So like not a solar cycle, but a whole entire day. So on Mars, we would call it a sol. So this matches up on the certain days that the rover took those photos. So they each just have the properties of things that the API has specified that you can get from them. And then the camera as well just refers to which camera on the rover is taking the photos, because the rover has multiple points that it's taking photos from. This isn't super helpful information, but you guys are going to come back to this project in a couple of weeks, and I think maybe even Monday. But it will help you kind of unit test, and you're going to add more things to it later down the road. So that's kind of why it's structured the way it is. Otherwise, I would have just cropped out a lot of things for you. Okay, we didn't even touch the storyboard today because it was already done for you. But if you didn't already notice, the storyboard is just a collection view, and all it is in each cell is just one singular image view. That's the only thing that's in there. And so the instructors have gone ahead and made that custom collection view cell for you. This image view.image is just a placeholder. So there's just a placeholder image that will go in there. There's not a whole lot that you need to know about this other than they made the custom cell and they added that image view outlet so that it can populate. All right, then let's talk a little bit about what comes in this photos collection view controller, because there's a lot that you guys might be familiar with and there's a lot that maybe you aren't familiar with. There are a couple of private properties in here, a couple of property observers as well that just take note. So if you kind of see like the kind of cascading effect here is there is that Mars rover struct that gathers the rover. There is the sol description, which talks about the particular day that the pictures were taken on. And then there's the photo references that depending on the rover and the day it was taken, it'll populate and reload the table view with that information. So these are just property observers. Sorry, these three right here. These are just property observers that are looking for certain things. So you don't actually need to access these a whole lot. There's not a whole lot of information involved with them. So don't worry too much if this is pretty Greek to you. And then in the viewed load, and the reason I'm going through this with you guys is because when I first opened this project, I was like, what the hell is going on? Because there was just so much in it, so much content. I didn't write any of it. And so, I mean, that's half the battle, right? You have to take like an hour just to kind of rifle through to see what's going on. And that's another big reason why I don't love this project. But the first time the network client is being called, which there's a fetch method here we'll look at here in just a second. But this fetch method is just being called when the view loads. So when the view comes up for the first time, it's going to make that network request. And then depending on how we've configured the data source, it's just going to pull images from the Mars rover and place them into the collection view cell. And then these are all the collection view data sources. You guys have worked a little bit with collection views before, so this should be somewhat familiar. One thing to point out, they are using an external function to load the image. There's a couple reasons for this happening. Before, you guys have worked with me on table view apps and things in that you can, from a network request, get like a URL, and then you could turn it into data and then turn that data into an image. There are a lot of ways that you could turn something into a UI image if it has the capacity to. The reason that we don't do that in here is because in a bit, this load image function is going to get pretty dense. There's going to be a lot going on in it, and we'll talk about why. But yeah, so that's just kind of the collection view data source there. And then there was that external function I was just referring to. So basically what's happening with this one is we target a certain cell at an index path, and then it can take those photo references that it got from the Mars rover. There's going to be a whole array of them. It can take an array of those photo references and pick each individual one to go into the collection view. Okay, we'll come back to this here in just a second and talk about what it's doing and why we don't want to do it this way. I've set it up just so it loads images. We'll do it in a sec. Okay, here is the Mars rover client. Now, I really want to draw your attention to this one, guys, because you won't use this to get this app to work. You won't even like touch a lot of this code, but there's such fantastic code in here that I think you should look at it. So particularly this one right here, this fetch method is very usable. This is super modular code because we talked about generics this week. This is a generic type being passed in. So this T could be whatever you want it to be. The T could be any sort of, last week Alex was working on a Harry Potter app and she was taking like characters from Harry Potter and she had a struct set up so that a character had a certain like Hogwarts house and they had a name and things like that. She could totally pass in that character as a generic type and this function would work for it. Obviously we'd have to tweak it a little bit so that, you know, this is particular to this project, but this code is super modular. This fetch method is fantastic. So I would make a code snippet if you guys want, or just come back to this, save it somehow, because this is a great method. A couple more things. Down here, this might have been kind of a surprise to you to see what this is, but basically what's happening here is that the URL is being adjusted depending on what sort of network request is being made. So if you were trying to access different endpoints for different things, in this case, the endpoint to get an image is different than the endpoint to get all the other information about something, then you could configure the URL to have different appending path components, and you wouldn't have to do it all in your data session, right? Like in your URL session, you could do it externally. So in this one in particular, this one is just looking for info about the rover. This one is looking for photos from the rover. So what's happening here is this is its own function. These are their own functions, but they're kind of being called in tandem to do different things. So if you go to the top here, this fetch Mars rover, the URL is being set with that function. So that for info for name. So instead of having to go in and modify that base URL with all this junk, you can do it externally and then just have it run here. So there are a lot of ways to do this, guys, but this is just like a cleaner modular way to adjust your base URLs. So I wanted to bring these to your attention just because it looks a little scary at first, but going forward, this is something that you can practice in your apps and it will clean up your code a lot. And if you ever have to make an adjustment to match an API, instead of having to go adjust the entire function, maybe it's just the endpoint you want to change, we can come into here and do that. So those are a couple of things just to point out that I think are helpful. Another big thing too, and this is so hard because like this project came with so much code and I want to go through it all with you guys, but I'd rather you understand what's critical for tomorrow. But this concurrent operation is a super boilerplate code. Like you can use this in a lot of circumstances. Pretty much anytime you're performing on a different concurrent threads, this is a fantastic resource to use because what it's doing is it's just saying, hey, there's 3 different states that an operation can take. It can be ready to execute, it can be currently executed, or it can be finished. And you'll see here in a little bit why it's critical that we want to know like which thread is done at a certain time so that the other threads can go. Because if you have multiple threads that think that they can execute at the same time and they're trying to do it all on the same thread, even like the main thread, it's messy. So this code, don't let it overwhelm you. Almost like the core data stack that we used a few weeks ago, this is super boilerplate. So we'll come back and you'll just paste this into your apps and anytime that you're making concurrent operations. In fact, I believe tomorrow, this is already inside the app queued up. The only difference in it being is that this is probably changed to the name of your project tomorrow, like this little astronomy label. So let this just be boilerplate code. Don't worry too much about what it does. It's managing your concurrent operations. Last thing, this URL plus secure. This is just changing any time that you use a URL. It's making sure that it meets a certain format, because you could format your URLs however you want it to be. In this particular instance, and a lot of APIs are like this, but it requires this HTTPS schema to be attached onto the beginning of it. And the instructors have just gone to the work of making sure that you don't have to do that every time you use a URL, which you'll see in a bit. We're going to do it a lot. So that was a lot. Do you guys have any questions about, I guess I should say this, what questions do you have about the current setup of the app?
I will comment, I think the HTTPS is also because iOS, unless you flip something in the project, it will not allow connections to just straight HTTP. They've actually disallowed that. All communications should be secure, or you have to go flip something to say, allow insecure communications.
Right. So yeah, I think this is a security aspect that they've gone to the work of figuring out. So this will also be featured in the app tomorrow. So like tomorrow, you're not going to have like a full-blown app like this one was today. You're going to get an Xcode project that's going to be fairly blank. Like there won't be a storyboard yet. You'll have to build that out and flesh it out, I'm pretty sure. But you will have this concurrent operation, and you will have this URL plus secure. So those are two things that you really won't need to worry about. They'll just be there for you. Okay, cool. Let's dig in. So if this feels overwhelming, that's fine, because the main bulk I want you guys to get out of this is just how to make a cache, how to make fetch operations, and how to get those operations to do the things that you want them to do. Okay, so if I run the app right now, and I hope it doesn't take too long, I probably should have run it first, but if I run the app right now, I have configured a data task to fetch images for a soul and populate them into the table view. And you'll see here in a second why the data task I've set up is not helpful. You guys might have touched this today in your afternoon project if you got there, but this whole thing where we're trying to load a ton of images at once can get really dicey. And so that's why we want to use multiple threads so that one thread can be loading images, one thread can be caching them for reuse, and another thread can be saying, hey, I don't need this anymore, so don't worry about fetching images at this point. So if I scroll through here, we can see the images are loading upon scroll, but like it's not very seamless, right? Like this is pretty chunky. Like I can see the scroll view kind of just like hampering as I keep going down. And then the other thing is too, is if I scroll all the way to the bottom and then I scroll back up a little bit, it's not doing a very good job of like ordering what is loaded. It's just kind of like free willy loading whatever it decides to load, which is really not what we want to happen, right? Because you know, if you're opening like a shared Google Photos app or something, you're not going to want to like scroll through photos and wait till each and every one downloads. You want it to be efficient and quick and see all your photos pull up. It's like this one's really struggling at this point. This is not great user interface. So the first thing that we're going to do to kind of correct this, alleviate this situation, is we're going to go, I can't decide if I want it. Yeah, we're going to start with a cache. So I'm going to tell you guys and teach you how to correctly implement a cache that's pretty modular that you guys will be able to use quite a bit. So I'm going to go into the model, and you can put your cache in a lot of places. I think a model is generally an okay place to do it because you're going to probably be caching your actual model. So I'm going to call it just cache. Okay, and I'm going to do a blank Swift file because we're kind of going to want to, I think that later you guys can probably just make a code snippet out of this as well. But let me just walk you through making a cache, and then going forward, like tomorrow, you should be able to use something pretty similar, if not the exact same, to get what you need done. So I'm going to make it a class, and it's going to be cache is the type that we're going to call it. And then what I want to do here is we could make this case specific to saving photos. We could save whatever we want here. We could do a lot of things. But I want my cache to be generic because, like I said, you want your code to be modular. So like not only in this astronomy project, but tomorrow and all the times forward where you're going to want to cache data, you can use this. Before I get into this, can anyone tell me why it would be smart to cache, like implement caching in an application? What do you guys think?
One reason is you don't want to have to pull a big block of data every time it's needed if you can cache it if there are no updates.
Yep.
Network.
That's exactly right, Josh. So like the beauty of a cache is that we don't necessarily have to store like images into it. We don't have to store these large files, but we can attribute some sorts of values to things that are saved. And then when those values are found, kind of like a dictionary, we can be giving it a value and it can do them quickly for us. Another big thing too is, yeah, like you said, images, if we wanted to make a big network request, like the one that we did here, it's gonna pull down like hundreds and hundreds of images. And we just don't want that to execute all at one time. We'd rather, you know, if some images have already been loaded, we want to have access back to them. We want to reuse them. You guys will see this happen. Like Instagram is a classic example of image caching, where even if you don't have internet, you don't have data, but you pull up Instagram, probably the last couple photos are still going to pull up and be visible because they've implemented a cache so that it pulls those kind of saved instances for you.
It's kind of like cookies, right?
Yeah, like cookie. It's just like saved so that your app can be performant even not on the most powerful network connection or when there's no network connection at all. So it's just a place to store things. So what we're going to do is we're going to give it a generic type. And
sorry, Mitchell.
Yeah,
so caching improves the performance by making things load faster, or saving things like more locally so that they can load faster. Is that what you're saying?
You're going to see, so what we're going to do, and I'll explain as I go, we're going to make our cache a dictionary. So what I'm going to do is I'm going to attribute a key to a value. Sorry. I'm going to attribute a key to a value. And so what we're going to do is we're going to save some sort of key, and then that key can directly be translated into a value, and it will pull things faster because of it. So think of like a directory, right? Or like a table of contents. If you told me that NS operation, well, I should pick a better one. Maybe like coding keys. We did those on Monday. If you gave me a Swift textbook and I wanted to know about coding keys, it's going to be way faster if you give me a key, like an integer or a value, like a number, so I can go find that specific page rather than having to scroll through and look through each individual page to find something. So caching kind of does the work of making a table of contents for you so that things can be quickly found or have like an address almost is a like a real world way I would say of it. So what we're going to do is we're going to make a dictionary. And sorry, I need to put this so the error goes away. We're going to make a dictionary, and you guys were supposed to do this today in your afternoon project, and I'll kind of explain why, but you want all of your keys to conform to hashable. So if you guys remember from, gosh, what day did we talk about it? Tuesday? Does anyone remember anything about hashable?
Does it have to do with like the way that the type can be like organized?
Yeah, something along those lines. So hashable, what it does is it can say if there are two different things, we can still make them tied together or like one and the same as long as they conform to hashable. So like for my key, and you'll see in a bit, for my key, I could have an integer. And for my value, I could have an image. But hashable, and I think hash tables have a lot to do with this, but just think like if you were on a grid, there's like an X layer and a Y layer. So like I have all my integers at the top, and then I have a rundown of like data or strings on the bottom. So if I wanted to find something that matched both of those aspects, there would be a specific number or a specific like square on a grid that would line up those two things. That's kind of what Hashable is doing here. Is it's saying, I'll give you something like an integer, and I can match it up to a string, and they can kind of equal each other, or they can, like a dictionary would, there's a key value pair. So that's what's happening with Hashable. You don't need to be an expert on Hashable to use it. I just wanted to explain that, like, we wanted our key, if it's in an integer, to be able to match up with our value. So don't let that overwhelm you. This is generically boilerplate code, so don't worry. Okay, so we're gonna do two things. And this is, for one, we're gonna make an instance of a cache. I think I'll make it private. Private, so it just lives inside of this class. But we're gonna make a cache, just like an instance of our cache right here. We're gonna make one, and it's just gonna be set up the same way as our kind of values are set up here in a dictionary form. We're gonna say, for every key, there's a value. And right now, I'm going to just make an empty one. So doing that is the same as just saying it's an empty bracket. I don't think this will run. It won't populate in the code. Yeah, it won't. So we're just making an instance of this cache, but it's going to be empty. So this, just for understanding purposes, this is a place to store our items. So we're storing keys and values in this cache. That's what we're making this for. And now the other thing that we need to do is that we want to make this thread safe. And what I mean by thread safe is that if there's a bunch of like shared resources, we don't want everyone to have free reign on just doing whatever they want with them. We want things to kind of be organized and people to access things in kind of their own operation queue. So what we're going to do now is that we're going to make, I'll make another private var, whoops. And this is going to be, I'll just call it queue. So we're going to make a queue, and it's going to be a serial queue. Do you guys remember the difference between a serial queue and like a non-serial queue, I guess I should say? Or like the best example of the serial queue Johnny mentioned today. Does anyone remember what it is?
So he described it as this the checkout line with basically one person's checking you out, basically.
Yeah, so the serial queue is the main thread. So it's like where everything's convergent. So like the checkout line, only one customer can be in at a time. Like people can line up in it, but only one person can be actually buying things at a time. Another great example is like a railway station where there's just one loading zone, but there's tons of trains coming in. So the best example of a serial queue, and the only example I would say, is your main thread, which is where our UI happens. That's where any sort of change that the user sees or can interact with happens on the serial queue. So we're gonna make this serial queue here, and I'm gonna just give it a label. And your label can be a lot of things. I think it's gonna be the same as, where did we make it earlier? In the concurrent operations? Yes. I'm just gonna make it the exact same as this state queue. So tomorrow, when you make your cache, come into your concurrent operations, and for the label, we just want our serial queue that we're making in the cache to be the same one as this state queue. It's really the only thing you need to know tomorrow to be dealing with the concurrent operations thread. Okay, so I'm gonna come in and I'm gonna set that label to be equal to the one that's in the concurrent operation. So what I did here is I gave, and I'll kind of write this out for you. This is a place for items to be cached. And then here, this is the serial queue. And it's going to make it so, well, the main purpose that I'm setting up this queue for is that we don't have to use NSLock. So the basic thing is so that everyone can use shared resources without using NSLock. And you guys don't worry too much about writing in these comments. I'll write them as they go to help you understand, but I will post the solution at the end so that you can come back. But the main reason that I'm making sure that the serial queue is put in here is so that we don't have to go back and use NSLock every time. The serial queue, because we're setting it up here, it means that only one thing can happen on that at a time. There can be more than one thing because there's a lot of UI engagements happening, but basically what's happening here is we don't want to use NSLock because it's going to be a pain to like lock and unlock every time. So this is the kind of beauty of this particular queue, so we don't have to do that. So you guys had fun making that yesterday with your spoon thing, but we don't actually have to do it, which is really nice. Okay, and then two other things that we're going to do in the cache is we need to have a place to add, have a function to add items to the cache. Like this cache up here, we have to have a function that will add them. And then I also need to have a function that returns items that are cached, right? Because like we can keep them saved, but we also need some sort of resource or function to pull out that information after it's been cached. Okay, so what we're going to do here is I'm just going to make a function called cache. And what we're going to do is we're going to take in both a value and we're also going to take in a key. Whoops, that needs to be lowercase. We're going to take in a value and a key. And then what we're going to do here in the return is that we're going to call it func value. And what this is going to do is that this one's going to take in a key and it's going to return a value for us. I'm going to put it as optional. That's what the solution code has, and it makes sense because if there's not a cached image and we call this function, we don't want it to crash. We're going to let it be optional in case that doesn't exist. So like I said, guys, a lot of this is boilerplate code. So some of it you just have to it's a big pill to swallow and you just have to do it. But tomorrow you'll generally be doing something very, very similar to this with your cache. Okay, so what we're going to do for the cache is that we want to add these items to the serial queue. So what I'm going to do here is I'm going to get into the queue and we're going to do this one asynchronously. And I'll explain why here in a second. And then on the queue, we're going to say the cache's key is going to be, well, whatever value we get for the cache's key, we're going to set equal to the value that we're saving as well. So, and this needs a self. So what's happening here is that every item needs to have a key and a value. And what we're saying is in the cache, if it has this key, it should also have this value. So the value that we pass in should match up with the key. Do you guys see me highlighting these? Nothing crazy is happening here. We're just making a dictionary. We're making a dictionary with a key and a value. You guys with me so far? Doing okay? I probably should open up everyone's Zoom picture so I can see you all. Okay, cool. Now let's go to the value. This is how we're going to return things that have been cached. So what we're going to do here is we're going to say return our queue. And the reason why I'm not going to do this asynchronously, we're going to do it synchronously. Well, I'll let you guys answer this. What do you think would be the reason for this needing to sync with another thread, like another operation happening, versus it could do it by itself whenever it wants? Why do you think I want this one to happen in tandem with another?
Because it may need the value that it's requesting before it can do another task.
Exactly. That's why this one's so critical. So like we can cache something whenever it comes up, but I can't return a value unless it's been cached. So that's why I'm doing this one synchronously. It needs to be in sync with a different thread. So a synchronous operation will work with other things, whereas an asynchronous operation can kind of do its own jam. It can kind of work on a thread that's just available for it. So what we're going to do here is we're going to just say the value that I want out of this should be equal to whatever, oh, not index, I'm sorry. Whatever value is attributed to the cache's certain number or a certain key. So to kind of clear this up for you guys, let's say I go to the grocery store and I want to get detergent. So what's happening here is the detergent will have both an aisle that it lives in and then maybe like a place in the aisle, like in a specific section or specific place, like maybe on the right-hand side in the first part of the aisle. But what I'm getting at is the key is like a number, right? It's the aisle that the detergent lives in. So when I come down here to find out where the detergent should be, where I can save it to be in like my memory, is I can say, okay, it lives on aisle 1, and then it's in this specific spot of aisle 1. That's what the value is doing. But the real thing I want to get to you is like this number is going to be critical. It's going to be kind of like an identifier. And so when we come down here, sorry, I'm going to open up the chat so I can hear everybody. Bye, Mark. See you later. And there's Ben talking to me about tomorrow so that I can complain to him about how this week was not my fave. Okay, so what we're saying here now is we're saying, hey, I want to find detergent. I know it's on aisle 1. So if it's on aisle 1, like tell me where the detergent is kind of thing. That's what's happening here. There's a dictionary that has a key and it has a value, and we can kind of use what we need to find those things. Okay, so don't let this overwhelm you guys. This is just kind of the way that a cache is built. What else can I help you understand about this so far? And if nothing else, as long as you have it written out, it'll work. It'll do its job. I'll show you how and why in a little bit.
So it's kind of like the keys we use for JSON when we were trying to access the JSON in the request. Is that right?
Yeah. So it's like if there's a JSON file and there's a name, we have to give it that name key to get what the actual name is or the value is out of it. That's what's happening here. Okay, rad. Let's keep going. And actually, we don't have to do a ton to get this project to do what we want. It's more of just like swallowing the big, bulky stuff. Okay, so I can't decide if I want to flesh out the entirety of our operations yet. Let's do that. Let's do that. Okay, so let's go ahead and we're going to make our operations. And what these operations are going to do for us is rather than on the main thread or a majority of the main thread doing all those fetch images, we're going to perform them on a background thread via concurrent operations. So I'm going to make a new Swift file and we'll throw it into the operations folder. Oh shoot, I didn't name it. That's fine. I don't want to refactor, so I'm just going to delete it. Whoops. Okay, let me make a new one, sorry. And you can, and here's the thing too, you guys can name them whatever you'd like, really. I'm going to name mine fetch photo operation. Because that's all we're really trying to do in this app, right? Is just fetch photos of these Mars pictures. Okay, cool. So now I'm going to walk you through kind of how to flesh out a concurrent operation and do it custom. So you can make your own custom operation to happen. This is kind of like a boilerplate code that you can use quite a bit. And like I'll teach you what's in and useful inside of this so that when you make your own custom operations like this one, you can access the things that you need. So the first thing that we're going to do is we're going to make a class and we're just going to call it fetch photo operation. And it is going to have a subclass. Does anyone want to take a gander or a guess at what the subclass might be for this?
Concurrent Operation.
Yep, because it's going to be a custom class of kind of a custom class we've already made. Concurrent Operation. And if this sounds familiar, like you guys got to this point in the afternoon project today, good, because that's what we're going for. All right, the first thing that I'm going to do is we need to make sure of a couple of things. So the first thing off the top of my head is I know that we're going to need a photo. And we're going to get that photo from a Mars photo reference. Because if I come up here, this is where the actual image information is. So like all of these other structs, like this is just the camera that's taking the photo. This is the day it happened. This is the machine that did it. But this is the actual photo, is this Mars photo reference. I wish they just would have called it Mars photo because I think that makes it sound a little bit more, sounds a little bit better. But this is what we're going to want to use to make sure that we get this particular image URL. Because the way the APIs work, they don't send down UI images to us. They send us URLs to them, or they send us data, or usually a URL though. So what I'm going to do here is I'm just going to say, okay, we need a photo before we can do anything, or we need a place to at least store a photo when it gets to that point. And another thing I'm going to do too is we need, I'm going to rephrase this. I'm going to call this photo reference just so I don't get myself screwed up. But you can call it whatever you want. The other thing I know that we're going to need is we're going to need image data. The way that it's set up in this particular solution code that we have is it's a private set, meaning that it can only be set within this class. And it's a variable, so it's going to change depending on photo and photo. But it's going to be our image data. So it's going to be this particular image URL. Like we're going to get this data from the image URL. I already know off the top of my head that we're going to need this. You'll see why in a little bit. And what I'm going to do is I'm going to make it of type data. This is what we're going to turn into a UI image. But I'm going to make it optional for now, because if we don't actually have it, things are not going to go super well, because we actually need, that data needs to be set in order to be used. It needs to actually be there. Two more things that we're going to add. We are going to add, just to make our life easier, we're going to make a URL session. And we're going to make a data task. This is just going to keep our code pretty clean later, so that I don't have to do too much work in here. And it can access all these properties that we're going to need here in a second without actually doing like completion handlers or closures for them. You'll see in a second, it'll be a lot easier to do it this way. I think tomorrow you'll definitely do it this way as well. Okay, so it's yelling at me right now. It's saying you don't have any initializers. So what we need to do is we need to create some sort of initializer that's going to make sure that we get these properties filled in, that we have like values for these properties if they're not optional. These ones are optional, right? Because we don't necessarily need a data task to occur yet. We don't know, or we don't need image data yet. We're going to hopefully get it. But we definitely need to have some sort of data that it's pulling down from the API. And then we definitely need to run some sort of network task to go back in and get the network information, to get like the URL from that specific picture. So I'm going to make an initializer. We're going to do, first thing, I'm going to pass in the photo reference. It's going to be of type Mars photo reference, sorry. It's going to be Mars photo reference. And then I'm also going to pass in that session, this URL session. And what I'm going to do is I'm going to give it a default value so that every time it runs it, I don't have to like go and type this out, because we always know we're going to have to use this URL session.shared. So that's just going to do one less line of code for you if we just initialize, we make it a default value here. Okay, cool. So let's do this. So we're going to say whatever our photo reference is, we're going to set it equal to what we pass into the initializer. So this guy is going to be the same as that guy. You guys can see me hovering over those. We're going to set them equal to them in the initializer. And then we're going to do the same thing for the session. And then I'm not exactly sure why they called super init here. I think it's because we're working within this concurrent operation queue. I think it needs to be initialized twice. I think we're super initializing what is already being done in the concurrent operation. But this is just something that I know I need from the solution code. It won't run without it. Don't ask me why. I don't have a good answer for you guys. All right, let's keep powering through. So and I'll show you here, this is of type operation, this concurrent operation. So every operation has two critical functions that you guys will need to use when you're executing your operations. You built them today, maybe. Does anyone know what those two functions are that work with that NS operation class?
Is it start and cancel?
Yes, those are the two. I'm going to just type out start. Yep. And I'm going to type out cancel. And it should pre-populate. You're knowing you're in a good spot if these pre-populate. So this override, what it's doing is it knows that NS operation, or just the operation class, has these functions where they're kind of autonomously starting and canceling, or like stopping things from happening on the threads, because your Xcode projects are really smart. They know how many cores the devices you're using have, and like they're smart enough to organize those things. This is just us doing the custom manual work of saying like, start doing this one on a background thread and then stop doing it on a background thread. This is happening all the time in your apps. We're just like taking charge of it in this particular application that you're building today. So we're going to implement a start function so that this whole like fetch photo process happens when we want it to on a background thread. And then we'll implement a cancel thing, like a function, to make sure it stops doing that. And you'll see why the reason that we want it to cancel is because in this particular app, we want to keep scrolling and seeing images, but we don't care about the images that aren't on the view anymore. So that's why the cancel is going to be critical. But the start we're going to need regardless, right? We're going to definitely want to put things on a background thread so that they can run their network tasks, and then we can put them on the main thread so that the UI updates with them. Okay, cool. So this is a little bit of boilerplate code as well. The first thing that we're going to do is inside your concurrent operations, there's an enum that's of type state. And the state just refers to one of these three aspects. Either the operation is ready to start, it is actually going, or it's done going. So first thing we're going to do is that when the operation starts, we're going to change the state so it turns into what state if it's starting. Is executing. So before this is happening, it's planning on is ready. Is ready is going to be kind of the default. It's set right here in this private var. The state is going to default to is ready. And so we're going to say state is executing. Now there's logic inside of this so that when it is ready, it can do what it needs to do. And this whole is executing thing is an enum that's even deeper under the hood. There's like a lot going on with this. If we had 3 more hours, I think it would be fun to go in and talk about kind of what these aspects are doing under the hood. But I think they're really telling in that this means it's ready to start. This means it's going, and this means it's done. It's really all you really need to know. So the first thing we're going to do is when the operation starts, we're going to change the state to is executing. And then what we need to do, and this was in your instructions today, but we need to make that a secure operation. This is where your URL plus secure is going to come in handy. It's going to make it safe. It's going to let you perform thread safe. It's not going to let it, have a super big struggle. It's not going to crash on the background thread if you end up running this and it's a bad URL. This is setting the URL up so it works, so it's safe. So what we're going to do here is we're going to declare our image URL. So we're going to say, let our image URL equal our photo reference. So this is where it comes in super handy to know what's kind of living in this app now. So we have a photo reference. And if I go into the photo reference, and this is why I don't like this project, because you had to know all this stuff when you didn't build it out. It's really tricky. But every photo reference has a couple of aspects. So every photo has an ID. It has a day it was taken. It has a camera it was taken on. It has the date on Earth when that date, when that picture was taken. It has an image URL. So these are the properties that we're going to want to access here. Particularly, we want to know the image URL aspect. And then this is where the URL plus secure comes in handy. So if you check this type, this is of type URL. And this is just an extension on URL, so that anytime there's a type of URL, it's going to apply these properties to make it safe. It's going to use this property, sorry, not property, is computed property. This is a computed property to change the URL so that it meets this kind of HTTPS schema and it's safe. Like Josh was saying, it's going to be secure and safe for you. So here we're going to access that HTTP using HTTPS method. If that seems crazy to you, don't worry. Tomorrow, this is just going to have like what you're going to use. You're just going to use this dot using HTTPS. I know it's going to yell at me here in a little bit, and we'll let it yell at us. We'll deal with it. Okay, so moving on. How do we, and this is a conceptual question that's taking a couple of weeks steps back for you guys, but how do we initiate a network request? Just in the dumbest form.
The URL session.shared.data task?
Exactly. So the nice thing here, I'll show you. I'm going to declare a task. And the nice thing about using this session up here and having a data task is that we can streamline it so it's all the same. We're using these same particular ones. So I'm going to do a session, which is just a URL session, right? Dot data task. And then that data task being of type URL session data task has all these different aspects that we can use. I don't want the completion handler here. Actually, I do want the completion handler. So we're going to do this one down here with URL and then a completion handler to pass it. So I'm going to double click this so it opens up. And then we'll deal with the rest in a second. But what URL do we want to be trying to look for or trying to use here?
Image URL.
Yep, this is where the image lives on the NASA website, is this particular photoreference.image URL. So back in the app up here, this particular Mars Rover is doing the work whenever the view loads to pull down all that information. So that information exists on the network, like we pulled it down from the network and we have access to it. But now we can run this session data task to particularly look at the URL that it gave back to us. Because it gave us a URL, which is just a string, but we need to do a whole separate data task to actually pull up that image in the background. So what I'm going to do is I'm just going to do some placeholder text here. So data, I don't care about the response because that's just more work here. So we're just going to worry about data and error. Someone walk me through, well, no, I'll keep doing it because I think this will make more sense to you guys here in a little bit. So what I'm going to do is I'm going to say if let error equals error, just taking care of our error handling. Oh, and this is yelling at us now. We'll fix that in a second. We're going to say if let error equals error. We're just going to ns log. I'll say error fetching data. And then we'll be really specific in case we run into an issue here. So we'll say for this particular photo reference, that's our struggle. And then we want to define the error as well. That way we can say, okay, this particular photo reference had this sort of error with it. That way, like if you know that the API has an issue and it's not actually your code, you save yourself a lot of grief. So like we could swap through different souls, we could swap through different rovers. And this error handling message is going to give us a lot more detailed information than just saying error fetching data for error. This will be more detailed for us. Okay, so this is yelling at us up here because our image URL is of type optional, and we don't want it to be optional here, right? Because like we don't want to run a data session unless we actually have this URL. So I'm just going to do a guardlet, and then we're just going to else return if that's the case. And that should be all good and get rid of at least that error. And this guy, oh, self. Because we're inside a closure, we have to refer to self. Okay, Cool. So now we've got this kind of queued up. What I can do now is that we've got this image data up here, and we have hopefully data that we got back from the data task. So what I'm going to do is, because this is a private set, we're going to set this now. So what I'm going to say is, and this is going to have me do self, I'm pretty sure, but what I'm going to do is I'm going to say image data is equal to data that we got back from our data task. Because this should be of type data. Whoops. This should be of type data, and this should be of type data. And we need to do self. Okay. So we're saying, hey, if there's an error, let's handle it. But if you get data back, aka from this image URL, we're just doing a conversion here. We're taking a URL and we're turning it into data with this data task.
You want to guardlet that?
You can do a lot of things. I think guardlet is the safest way to do it, to make sure that we actually got an image URL from our Mars photo reference.
No, I mean for the data could be blank as well.
Well, at this point, it won't run anyways if the image are you talking about this data right here?
No, in 31.
We could.
A lot of check for error and then check for data. Then.
Yeah, we normally do. You're right. Yeah, let's just say guardlet data equal data, else return. And then, yeah, you're right. We can always check that. Self.image data, if it'll come, equals data. Yeah, that'd be good too. That's very like safe handling. In fact, the solution code doesn't even have it. So good point, Josh. Okay. Now, a couple of things are missing. Josh, you're the master of this one. You know that there's one thing missing at the end of this that I helped you with last week.
Yeah, resume.
Yep. So we've got the task up here. So what we're going to do is we're going to call just task.resume. I mean, you guys have done this a number of ways, but you could just have jumped into the URL session.dataTask and then just called .resume, but we gave it a place to live, so we can just say task.resume. And then for whatever reason in the solution code, they did have that private var of data task, and then they just set it equal to the task here at the end. So data task is equal to the task. If you guys were to ask me to set this up a different way, I would do it differently, but there's probably a reason behind setting these particular variables here. It's not how I normally do it, but I'm sure they had a good reason for it. Okay, now if we look at, I'll come back here. This is your assignment for the day. If we look up here, I don't remember where it said it. Okay, so they asked about using defer here. So they said this is a good use case for defer. So one, did you guys figure out what defer was? And two, do you feel like you figured out how to apply it or how to implement it?
I looked it up, and so I did my defer statement after, I did it right at the beginning of my start method and then did defer self.state equals finished. And I did the start, or the state is executing first and then the defer statement. I don't know if that's right or not, but that's what I did.
That's how the solution code has it. It just does one thing differently. It actually is going to put it inside the data task. So okay. You had it exactly right, Alex. What defer is doing is it's saying, wait to do this particular thing until a certain state is achieved. In this particular case, we care about the state of the operation. So .state. And I think it needs a self. Yeah. Self.state is equal to the state of .finished is finished. So what's happening here is it's saying, hey, don't get to the state of is finished until this task has run. So wait to do this, wait to change the state to is finished until this is over with. Another kind of error handling aspect or something good to use as well is it's said if self dot is canceled, so like if it ends up getting into a state where it is canceled, just go ahead and return out of the function. So we're kind of preemptively handling situations to make sure that, one, we don't get to that is finished state until this task is finished. And two, if it ends up entering that is canceled state, we don't want to run this anymore. We want to be done with it. You guys with me so far?
Mhm.
I feel like this is a lot of what actually the morning project should have been. It's like me showing you how to do this, and then you guys actually doing
agreed. I'm not muted.
rather than you seeing it for maybe the first time tonight, the night before you're going to use it tomorrow, which is, I'm sorry, that's frustrating. Okay, so yeah, Alex, you were definitely on the right track. This is how it's implemented in solution code. I think that there are probably multiple cases where you could put this throughout the actual start function, but in particular, they did it within the data task, so that it said like, hey, run this data task, do it as long as you need, and then you can get to is finished once it's over. But if it doesn't ever finish for some reason, or if it cancels out, we can change that state as well. Back in your concurrent operations, those are computed properties that are changing depending on what state is specified. These three right here. Okay, cool. So about the start function, what questions do you guys have? We're actually almost done too.
I'm having on sync. Yeah, on 27, I've got a warning that says constant task inferred to have type void, which may be unexpected, which then throws an error when I try to assign tasks to self data tasks because they're not the same type.
You're trying to resume out of your like task property itself. Go down on the next line and do task.resume.
Thank you.
Yeah, the resume needs to be done right at that end closure. So like data task is within this closure, and then you call resume at the end. Perfect. All right. Good so far? Okay, awesome. Let's do the cancel, because the cancel is actually super easy.
I'm so excited for the cancel. That's what I've been stuck on this entire time.
You're gonna laugh, Alex. Okay, so the reason that and I'm seeing now this is the real reason why, but we wanted this data task to be accessible both within the start function and the cancel function.
I'm mad already.
If you imagine, like, we can't specify them. Like if I wrote out one, they're mutually exclusive. But if I make like an overarching one in the class, this data task, then I can use it in both functions. So like we used it here, and now I'm going to use it here. So I'm going to say data task dot cancel. Alex, your face. I loved it. That's all it is. That's just, there's a cancel property.
That's so stupid right now.
Right. So every URL session data task has a dot cancel property, and it does exactly what you think it does. I'm pretty sure you can go in and check. This method returns immediately, marking the task as being canceled. So it just ends the task. It just cuts it off. It's the red X in the corner that you just hit, and it ends the data task. And then another thing, because we have to do this because we've got this concurrent operation that's kind of working all on this NS operation class, there's a super method to call as well, just one more line of code. So it's just called super.cancel. And so what this does is that it cancels the entire operation. So it finishes not only the data task, but everything else that might be executing, so like the initialization. It's closing out the data task and the operation. So this is for closing the data task. This is for closing our fetch photo operation. Are you happy to see that that's only 2 lines of code and like 16 characters, Alex?
You have to know. Like, I was sitting there like, and we got in stand up, and Jake was like, I got everything with the cancel. I was like, same. What is wrong with this cancel?
This is all it is. Yeah,
Wow.
you don't have to run a data task to cancel it. Maybe you guys were getting into that aspect, but there's just a simple cancel aspect that you use. That's it. So, all right, guys, let's take a brief break. I mean, there's only 4 of us, so take as long as you need, but let's do 2 or 3 minutes, and then we'll regroup here in just a sec. So get up, stretch, go to the bathroom if you need to. I'm going to commit this because I haven't been committing at all. This has been Brad practice, but I'm going to say configure cache and set up fetch photo operation.
I just hope that all of you are treating yourself to a cocktail tomorrow night after the sprint challenge.
Me as well, after dealing with all of you guys after you deal with it. I'm also going to do that.
My best friend's like, she's like, I love Fridays because I know you need a drink.
Yep. Well, and that's like the motive. That's like a big motivation, right? Is like you get to Friday and you really want to get the sprint challenge done so you can have your weekend, because otherwise you're going to spend the weekend working on the sprint challenge. It's just going to be awful.
Yeah. Oh,
So,
yeah.
it blows my mind. I've had students, not you guys, but I've had other students that they'll get to the sprint challenge and they'll be like, I can't do this in 3 hours, so I'm just going to do it over the weekend. And I'm like, that's so dumb, because 1, you're running the risk of getting flexed, which isn't a bad thing, but you're running the risk of getting flexed. But 2, you've lost your whole weekend. You can you're supposed to decompress and chill and have a drink over the weekend,
Yes.
So I agree.
Yeah, no, I'm sprinting through it. I'm shooting for 2 hours flat so that I can be on my merry way.
How's your daylight situation right now, Alex? Do you guys?
I just flew back to Oklahoma last weekend.
Oh, so you've been in Alaska, but now you're back in Oklahoma.
Yes, I was in Alaska for 6 weeks. So all last unit, I was in Alaska, but I'm back home now.
Gotcha. I was gonna say, I was like, here and then I would check your video and I'm like, it doesn't look very dark in Alaska. You'd think it would be dark already, but.
Oh yeah, no, it's getting dark. Like when I left, the sun would rise around 9:30 and set about 6.
That is awful. I would not do well with that.
But the summertime is stunning. And it's daylight. I mean, you're asleep while it's daylight outside. It's wild.
That is wild. I have a lot of friends that they will hike late at night, even though it's 11 o'clock at night, but it's still super bright, and they are out hiking. And
Yeah.
It blows my mind.
Yeah. And the hiking is fun because you can do longer hikes and see deeper places in Alaska because you have more daylight to hike. As opposed to I mean, I know when I hiked in the Big Basin, we did a super long hike, but it should have been, we probably should have separated it over a couple of days, but it started to get dark, in the last probably hour of our hike, which is irresponsible.
Is wild to me. That blows my mind.
Did you end up fishing? Did you go fishing?
Oh yeah, salmon and halibut.
Nice.
Yeah, my brother-in-law went 2 weeks ago and came home with a freezer full of, they shipped it to him, but now we have a freezer full of salmon, and it is awesome.
Alaskan salmon's amazing. It's one of the best.
So good.
Honestly, halibut's my favorite. And so I think while I was there, we had just caught one. Well, my stepdad just caught one right before I got there. And there were 80 fillets, 80. I ate all of them over the course of my time there.
I mean, 6
Great.
weeks, you ate 1 a day, 2 a day. That's pretty good.
Yeah.
That's awesome. Oh, I'm jealous. I love seafood.
Same. I'm pescatarian, so that's really all I eat.
Perfect. That's so nice. Yeah, there's no fish in Utah. I mean, there are fish, there are rivers, but fresh fish is not really a thing. So
I didn't know you were in Utah. I thought you were in Idaho.
No, that's Hayden. Hayden's in Idaho.
Okay.
In fact, I went to lunch with Jonah yesterday. I should have taken, so Jonah and Hayden and Brian and I all went to a Lambda luncheon yesterday.
Oh,
and
cool.
we need to take a picture and post it in the channel, so everyone will be like, what the devil? But we forgot. But so Jonah and I are both 20 minutes away from each other here. which is crazy.
I wish I was close enough to go to luncheon with all you guys.
Well, go to your Lambda meetups. Everyone's got their Lambda meetups somewhere. I'm sure you guys have fun stuff going on.
There are no Lambda meetups anywhere near me.
Really? There's not like a Tulsa channel or something? Or are you pretty far?
I mean, I'm like 2 hours from Tulsa, but I mean, that's not bad. I need to look. I guess I haven't thought about looking because I figured it'd be in Oklahoma City, which is like 3.5 hours, and I'm just gonna go to Dallas for the weekend if that's the case.
Yeah, that's true. Yeah, look for your Lambda meetups. I know like the LA one, there's a lot of people. I think they do some fun stuff.
I'm actually in NorCal now.
Oh, you are?
Yeah. I've been going through a lot of different moves during Lambda. It's been crazy.
That is crazy. I had no idea. I always thought that you were in LA. Huh.
Yeah, I was, but
well, NorCal, they have way more stuff going on. I mean, that's where Lambda HQ is in San Francisco, but there's a lot going on there. So
cool.
Fun stuff. All right, guys, let's finish this guy out. The rest of the work that we have to do is actually just in the collection view controller. So before we move away from this fetch op, photo op, which we're gonna, actually call here in a second, we're gonna make it do stuff. Do you guys have questions about the cache or the fetch photo op that I can go over with you right now?
I have a question about the cancel.
Sure.
Oh my gosh, never mind, because it's a class. Never mind, that's a dumb question.
You're good.
We're gonna call it later.
yeah, you'll see it in a second. Yeah, it just lives in the class because we're gonna have access to it in a bit. So
got it.
All right, so let's move into the photo collection view controller. And we're gonna do a couple of things. For one, there are a couple of properties. Whoa, I spelled properties way dumb there. There are a couple of properties that we haven't added yet that we're gonna need to have access to. So for one, we're definitely gonna wanna have those two classes that we just made. I'm gonna do a private. I mean, you don't have to do private, but I mean, if
I wanted to comment, like you said, when I first downloaded this project, it took me an hour. I just went through the whole thing, and it's kind of sick how long it took me to figure out that they put the properties down at the bottom. But I remember you saying that before. Like there was a client dot something. I was like, who the hell defined client? Where the hell did client come from? So finally I remembered to like just click on it and go, oh, they put them all at the bottom.
Yep.
It's like, okay, who does that?
I know. That was a thing for a long time. In fact, the majority of the time that I was in Lambda, they said, hey, put your properties at the bottom. Put your outlets and properties at the bottom. And I was like, why? And there was a whole debate about it. And I think they've come to the conclusion that putting them at the top is the place to put them. I also think, like you've said before, Josh, like it's just intuitive to put them at the top to like see what you're dealing with, So I switched these up for your guys' sake and put the properties at the top to help you out. All right, so let's go and declare first our cache. So this is the fun part because we made our cache of generic type. So what I can do is actually I should do this. So here's our cache, and then here's where the generics concept comes in. So this is how to set up a generic type, right? You've got these two like arrow braces, and then we're gonna have to initialize it. But inside of these braces are where we're gonna put the type, where this particular type is going to be manifest. Now, in here, we've set it to have both a key and a value. So there's not only going to be one type, there's going to be two types. And I'll show you how and why in just a sec. So the first type that we're going to attribute to the key, we're going to make it an integer. And the second type, we are going to attribute to data. Before we do anything with these, does someone want to tell me maybe why this is a good idea, or like why I'm going about doing it this way?
Well, because we're setting basically like an identifier for the picture, and then we need the data that goes with that identifier. Like
exactly. And the cool part is with this particular project is that these already have an ID. Every photo already has an ID. So we might as well just use it. Because if every photo has an ID, we don't have to make an identifier for it. It can just be like, hey, every photo has the ID, and then we can attribute that in our key for our cache. So tomorrow, I believe it's somewhat similar. But you could do strings if you wanted to. Like strings can be indicative of keys. There's a lot of ways to do things. So yeah, that's what we're gonna do first. We're gonna make our cache. And then the other thing I'm gonna do is I'm gonna make our photo fetch operation. Oops, I'm so sorry, photo fetch queue. So this is where we're gonna be, this is the background thread that we're gonna do all these on. This is all the operations that are happening with our photo fetch operation. And does anyone know what type to make these? This is kind of a question I don't expect you guys to know, but does anyone know what type a background thread would be of? That's fine. I didn't really expect you guys to know, and like I didn't remember this very well until I looked at the solution code, but it's of type operation code. I'm sorry, operation queue. And if sorry, I went into that a little bit fast. We can look at it here. Where is it? So it says a queue that regulates the execution of operations. So if we have background operations we want to perform, we want to do them on an operation queue. Question, is this a serial queue?
No.
Tell me why, Josh.
I don't know. I just remember him talking about today, to make it a serial queue, you had to give it a max operations, concurrent operations to 1.
So this is going to be a great interview question, I think, that you guys might get asked about concurrency, is like serial queues versus background queues. So the serial queue is your main thread. That's where UI happens. That's where like user interaction happens. So we don't want this photo fetch to be occurring on the main thread. We want to do it in the background, have the photos pull up, and then we switch it onto the main thread once those photos are available so that the UI kind of updates when they scroll. So this is not a serial queue. This is a background queue. So if you guys don't remember anything from tonight, remember that a serial queue is your main thread. That's where UI happens. It's where the user is actually touching the app and working with the app.
So our main.async is our serial queue, pretty much?
When you do dispatch queue, let me find one here. Yeah, when you guys do dispatch queue, main.async, this means, hey, the dispatch queue, FIFO, right? We talked a little bit about FIFO, so like whatever operations come in, happen, and then they get out. Your dispatch queue is your serial, and the operation queue is your background. So these two are like, they work in tandem, but they're different queues. So dispatch queue is the main thread, operations queue is your background thread. And when you guys do dispatch queue.main.async, you say, hey, whenever you're ready for it, throw this on the main queue. Update the UI with whatever this is. That's why whenever you call async on the dispatch queue, it gives you a closure, because inside of that, you're going to do some sort of like update views or reload data or reload the table view, some of those things.
So how does concurrency relate to like the serial queue versus like your background queue type of thing?
So that's kind of what the whole purpose of this that we're going to apply here in a second is like, you don't want to perform things on the main queue because it will slow down the user interaction. You only have a set amount of cores to work with. This goes into like deep computer science stuff, but you have a set amount of cores to work with, and a core can do a different thing than another core, and then they can kind of work in tandem to happen. But if you did everything on the main thread, it would be super, super slow. So like, you guys remember back in the day with like dial-up internet, where you'd like type in a URL and it would take its just sweet ass time to show up? That was because your computer had a smaller core, or maybe it was just one, and it was trying to do everything effectively like on one thread, because it really didn't have a lot of threads to work on. It didn't have operations to like work with back in the day. But now, like, units, devices, computers have multiple cores, and you can do things that can run on different threads. So it's kind of like, How do I phrase this? Because humans don't do this really well. We all work on a main queue. We can only do like one. We're not good multitaskers.
That's called time division multiplication, time division slicing. So it's like you have a circle. It can only do this. It only has a circle to go. It's like however long it takes to do an operation. So then it simulates multitasking by doing a little bit on each task for a little bit of time.
So it's kind of like,
and then continues that cycle, and that way everything gets a little bit done at once. It looks like it's all moving at once, but it's not. It can only do one thing at a time, one operation.
so it's kind of like disks and like RAM or something, where if you have too much stuff taking up your RAM, it's going to slow everything down.
Yeah, I mean, the main, so like, this is the biggest thing, and especially now that I'm studying for interviews and like going into coding challenges and talking about technical aspects of code, concurrency is a big issue because they really want people to know that if you do stuff on the main thread, it's going to slow it down. That's like the main thing to hammer out. And so if you can take advantage of multiple cores, because that's why we have them, is because they can do a lot of things at once, like Josh was saying. If we can take advantage of multiple cores and do little things at once, then we can kind of culminate that all when it's completed and then make things happen on the main thread. I think of it a lot like if you're building a house, then there are multiple people working on your house, right? Like, especially when it's at the end state, you've got people like electricians coming in, you've got plumbers working on things, you've got people working on the installation. There's a lot of aspects. There's a painter that's going to come in, bunch of different things. If you had one person doing all those things, it would take forever. But the beauty of concurrency is that we can have multiple people do jobs, and then they can all come together and produce the finished product faster than one person would have produced. Does that make sense, Will?
Yeah. Thanks.
That's like the main goal of this project, is to show you how we can do that. So let's jump in. I'm going to add one more thing, and this is going to be bigger, smaller, just depending on how many operations you guys have. But what we're going to do is we're going to say, we're going to do another private let. Actually, I'm going to do a var because it's going to change depending on what the operation is. We're going to do a private var, and we're going to say, we're going to call operations. It's like all the different operations that are going to happen, aka for one, definitely our photo fetch queue. But we're going to kind of split our photo fetch queue up in a little bit here in a sec. So I'm going to do another dictionary, and it's going to be a dictionary that has an integer on the left, which this will tie back to that photos ID, and then it's going to have an operation on the right. So that comes back to our NS operation, or just operation type here. So you'll see here in a second why we're going to do this, but we're going to attribute each operation to both have an identifying integer depending on the photos, and then what needs to get done. So if that doesn't make sense to you, don't worry. We're going to come back to this in a second. You'll see how it's going to work. But for now, we've got access to both of these things that we need. We need to have our cache to store images and their key values, and then we're going to need to have that photo fetch queue that's going to actually fetch the image data for us on a background queue instead of the main queue. Okay, cool. Now, we don't have a ton left to do, you guys. We're pretty much there. Now, I've got this method that I'm using right now, this load image, but it's doing the same URL session data task that you guys have been pretty used to doing. We run a data task with a URL, which is that same URL from the image. It gets back a data. If there is an error, we did some error handling. But if there is data, then it can just go ahead and make a UI image out of it. But if you can imagine, every single image would need to do this, and it's all happening on the main queue. This isn't, well, I guess we're throwing it on the main queue here, but you'll see in a second why doing this on a background queue is going to speed this up. It's going to do it so much faster. It's going to do it so much better. This is the slow way of doing it, not very efficient. So instead, we're going to use operations to handle it. So you guys can either comment this out or you can just delete it because we're going to get rid of it. I can't decide if I want to keep, yeah, no, let's take this out. All you need is just this photo references index path. Okay, So let's start. So I'm gonna kind of split this up into the different tasks that we need to do. So the first thing is we're gonna check if there is cache data. Because if the data is already run and we have a cached value for it, we don't want to actually go and run the data session again. We would rather just pull out it from the cache, right? Because that'll save us the work of running a network request every single time. So what we can do is we can say if let cached data equal, and then up here we've got our cache that we can use. So every cache has both an integer value and a data that we've attributed to it. So AKA comes back to the ID and the image URL that's been turned into a data based on our photo fetch operation. So we'll come back down here. Sorry, I keep jumping around. But we'll say if our cache data, we're going to set it equal to the cache. And then every cache, like I was just saying, has both a key and a value. So what I'm going to pass in here is we're just going to start with the value. Or I'm sorry, the key. And then what would I pass in here to find a specific picture?
Cell.id.
Not cell.id, you're close. And the warning.
Reference.id. Sorry.
Yep, photo reference.id. Yep, perfect. Photo reference.id. Okay. And then the other thing I'm going to do is, if there is one, I need to convert it, because right now this cache data is going to be of type data. I need to turn it into an actual UI image. So how do I turn, and I'll say let image equal, how do I turn data into an image?
UI image from data.
UI image, and then open parentheses, and then data, right? And then I'll just pass in our cache data. So what this one did is it just checked, hey, if you have data and you can turn it into a UI image, do that. And then what we'll do here is we'll just say cell.imageview.image is equal to our image, this image right up here. And then I do need to return out of this, I'm pretty sure. So the beauty of this and the beauty of the cache is that we don't even need to run a network request if we already have cache data of it. So setting up the cache this way is saying, like, give everything an attributed key and value, AKA, and I'm gonna have to scroll to the top here, everything's gonna have an integer and data. If we already have it saved, just pull it out. Don't bother to run the network request. But if we don't have that image, then we can run our data task. So now let's start our fetch operation. Okay, so tricky question for you. How do I start this fetch photo operation? How do I make it happen? How do I get this guy to do stuff?
Add it to the queue.
Yeah, so, and we'll do it here in a little bit. The tricky part is like, here, I'll show you in a second. So photo fetch queue is that queue that we made, right? And then it has an aspect called add operation. So what we're gonna do is we're going to make some operations to happen. It's like Inception, right? We've got our photo fetch queue that's performing the fetch to find images, but we're going to make some operations happen with that. This is why Johnny showed you guys block operations today. So what I'm going to do is I'm going to say, and we're within a closure, we're within a function right now, so we have to do this. So I'm going to say let photo operation, we can just call it photo op, be equal to, actually, I'm going to call it fetch op because that'll be a little bit more telling about what it is. I'm going to say let fetch op equal our fetch photo operation. And then if you'll see here, we had it pass in some information on purpose in the initializer. The cool thing is too, this second initializer we don't need. I'll tell you that this one's the right one, But why don't I need to pass in a URL session data task here?
Because it's going to be performing one.
Yeah, it's already doing it inside our fetch photo operation. We already gave it this URL session.shared for a default value. And when it runs this start, it's just going to do it. It's going to do our data task for us. So we don't need to worry. Okay, so what's the photo reference that we need to pass in here?
One from above.
Yep, the one right up here on line 97. Okay, perfect. So we're going to say, here's our here's our fetch operation. And now that we have this, I'll let you guys see there are, what do I want to say? So now, like Josh said, I can say photo fetch queue dot add operation, and then now I can add in our fetch operation. So what I've done here is I've declared a class-wise instance. It lives inside our collection view controller. I've declared that instance of our fetch photo operation. I've passed in this photo reference that it's fed me, and now I can add that onto our background queue via add operations. So every single what type is this? Let me check again, sorry. Every single operation queue thread has this dot add operation operator, where that you can add in anything that's of type concurrent operation. So that's why we did it that particular way. That's why this boilerplate code comes in so handy. It's because it's already like attuned and customized to work in this sense where you say, hey, I've got a background thread and I've got an operation. Let's just have them work in tandem. I can throw this fetch op on there. Because otherwise you guys have been dealing with like type errors and like, it doesn't conform to this type, blah, blah, blah. That's why this concurrent operation.swift file is so modular and helpful. Okay. So kind of a tricky issue here. We actually haven't cached images yet. We've declared our cache variable, but we have to make another operation to actually cache them within this background queue. So this is going to be a lot, but just go with it here and I'll explain in a second. So now we're going to make a cache op. And now we're going to make this of type block operation. So if you look at block operation, it says an operation that manages the concurrent execution of one or more blocks. So realistically, we could have made our fetch photo operation a block operation. It's just like a block of code that you can use. The reason we did it is because it's pretty bulky. There's like a lot going on here. So, and for another reason, we made a custom class here. But now what we can do is we can make a smaller operation without having to bother to like make a code file for it, but we can still run things on this background thread that are case specific, AKA caching an image. So this is going to be a separate operation that's going to occur within this background thread to cache our images. We're going to do this all on the background thread. So what we're going to do here is we're going to say if let data, so if there is data within our fetch op, and this is like, it's so hard to remember what's in your files that you were just working in, but this particular fetch photo operation has an image data. It's a private set, but it's being set here once the data task is run. So if the data task runs correctly, this data will go from being an optional nil value to actually having data inside of it. So we can say here, hey, if we actually have data in the fetch op, which the fetch op has that right there, right? Like that image data property. If it has it, let's save it. So now this is the magic part. This is how you cache images. This is how you use your cache. Sorry, not caching images, it's caching data. But we're going to say self.cache. So this is our cache up here that we've declared, our custom cache. And then within our cache, we have that property, the dictionary property in here that takes in both a value and a key. And I probably should have named it something different, but I mean, here's our cache, and then here's the property inside of it that's the dictionary. This is how the solution code was, and I feel like naming them the same thing was silly, but it'll do the job for you. So we'll go into our class-specific cache, and then that class-specific cache has a cache property that's a dictionary. So what do I want to pass in here for the, and these are backwards, sorry, but what do I want to pass in for the key?
Oh, the photo reference.id.
Yes. Good eye. Reference.id, so that's the number attributed to each picture. And then what do I want to pass in for the data?
The data. The
Yep,
data.
the one right above. So what's happening here is it's saying, hey, if you get data from the fetch operation, cache it in this dictionary. And every dictionary is going to have a number and data attributed to that number. I don't like that these are backwards. That should also be flipped, but it's whatever. Yeah, I think it's right here. We should have flipped these, but oh well. Does that make sense to you guys, this whole aspect that's happening?
It's coming full circle. It's
Okay,
coming.
we're gonna get there, Alex. We're gonna get there here in just a second. So what I'm gonna do now is we're gonna use this cache op, and you're gonna see how it works here. So every single block operation has a property called add dependency. So this, and I should have done that again. Sorry, I keep doing that. So if you look down at the tiny documentation, it says, makes the receiver dependent on the completion of a specified operation. So in here, we're going to pass in an operation that has to happen before cache op can happen. Do you guys want to take a guess at what that operation would be?
Fetch op.
Yep. So this add dependency means that cache op cannot happen until fetch op is done. It is dependent on fetch op to finish before it can go. So it's saying we don't want to cache in image data unless we've run all this code and the data task to actually find an image. Does that make sense to you guys? Was there like some light bulbs clicking? That's the cool part about block operation. We don't need to make a separate file. We can just kind of do a separate operation and then put it, like file it into the queue.
That's pretty nifty.
It is neat. It's really cool. So now let's do another one. Let's do another block operation, and this one is going to actually set the image. Because right, like we want to fetch the image's data, cache it, and then we want it to pop up in the table view or in the collection view. So this next one I'm going to make is I'm going to call it completion op, is what the solution code has. You can name it whatever is like helpful to you. So this is going to be another block operation. And in this particular one, we want to get back into this dictionary. We want to get back into the dictionary, and we just really care about the data here. And this doesn't have to rely on the cache op actually, because I mean, the real only time that we are worried about using the cached images is here, right? These lines 100 through 104. That's the only time the cache really comes in handy for us. For the completion op, we could have it rely on the cache, or we could have it just, that would be kind of redundant to do it again here. So let's have it rely on the actual fetch operation. So what I'm going to do here is I'm going to define the index path. And I'll tell you why in a second. We're going to say if let current index path equal our self.collection view dot index path. And I think, yeah, this one right here. So we want our it's hard to visually think of this. We want to make sure that each index path is lining up with the index path under the hood of our collection view. So we're going to say if we got the same index path, you know, like if the top left index path is the same as the one working on the operation queue, then we want to execute some code. We want to make something happen. Specifically the collection views index path. And then this is just for like error handling. You're going to see this here in a second. We're going to say current index path does not equal index path. These two are not the same, by the way. These are different index paths. This index path is referring to this one up here, this for item at, which is not dependent on like the view that we're seeing. It's every single item that's ever been shown up on the scroll view. If this doesn't make sense to you guys, that's okay. This is just this is more of an error handling thing than anything. This is going to show us if we got an image for everything. So we're going to say got image for reused cell. This is just going to show you that if we did the completion op correctly, that cells got reused. They weren't like, it wasn't the same cell that we just scrolled back up to. It's actually that we scrolled down and the same cell in the top left corner now has a different image inside of it. If that makes sense. If it doesn't, that's okay. You'll see it here in a little bit when we actually run the app. Okay, cool. Now, last thing that we need to do, and this was totally optional code, guys. Like we totally didn't need to do this. You'll just see why in a second, why it's gonna help. But now we need to just do the same thing. We need to convert our data that we got from the fetch operation into an image. Does someone want to walk me through maybe how I could do that? It's like we did it on line 110, pretty much.
Yeah, well, yeah, I was thinking like self.cache value and then change that value into a UI image.
Well, the cool thing is that we aren't reliant on the cache at this point. We're just more reliant on that the fetch operation completed. Because if the image is already cached, sorry, I keep saying image, it's data. If the data is already cached, lines 100 through 104 are going to take care of that for us. They're not going to run the network request, and it's just going to populate the cell with the image that's been cached rather than making a network call. So we're not really worried about the cache operation. This is just to save it, and then this will load it if it's there. But here at this point, all we need to do is we just need to say if let data equals our fetch ops data, sorry, fetch op dot image data. Then instead of going into the cache now, what we can just do instead is we can say cell, here's the cell that we're passing in right here, right? Cell dot image view dot image is equal to what?
UI image for data.
Yep. Now, I don't know what would happen if we decided to opt out of, I mean, we could probably make some more conditionals and wrap these two operations together. But for whatever reason in the solution code, they separated them. And I think there is logic behind that. I bet if I put them in the same, it would just be slower. But they have separate operations that are dependent on the fetch operation being completed. So this one's just going to do the work of saving, and this one's going to do the work of populating the image. So this is yelling at us now, saying like, hey, you never actually used this. So how do I add this, or how do I apply this completion operation that I did?
Did you want to do a dependency, add a dependency to the completion op?
That's exactly what we're going to do. We're going to do completion op dot add dependency. And what are we dependent on happening? What does this operation need to have happen first before it can occur?
Fetch op.
Yep, fetch op. And the reason that I don't put cache op is because to show the images, is a different task than caching them. They're not things that need to rely on each other. They can work separately. That's the beauty of concurrency, right? We can have separate things do what they need to, and they don't have to like work on the same thread or work in tandem. So that's why I'm adding the dependency to be on the fetch op, because that's just the more important thing here. Okay, rad. So,
And then can we send an array of operations to add operation?
yes. So what we're gonna do, and there's actually one more thing that I want you guys to add in. It's this defer. So we're gonna defer on something here in this completion op. What we're gonna do is we're gonna say, so our operations that we made up here, it's an array of operations that are happening, and every operation has both an integer value and an operation to match up with. So what we want to do is we say, hey, when it's completed, go ahead and remove the attributed values to it. So the way that this is going to work is we're going to say self.operations. And the reason that self keeps coming up is because we're within a closure, right? We have to reference self within like the body of a function. So all of our operations have this remove value aspect. So it says removes the given key and its associated value from the dictionary. So what's happening here is every time an operation runs to fetch an image for a collection view cell, it attributes memory to that particular aspect so that it can happen. Now, if you can imagine, if we had thousands of cells, the last thing that we would want is for every single one of those operations to be archived even when they're done happening. So what this is going to do is the completion op is going to populate those cells once they've got the information they need. And once it's done with this defer statement, we can actually get rid of to free up memory for these things. So we're going to say remove value. And you guys know what the key is for this particular dictionary for when we remove these operations.
Photo reference dot ID.
Exactly. Are you guys seeing the beauty of like identifiers a little bit? They're going to save you a lot of
I
grief.
love identifiers.
They're so great. Having an integer attributed to something is just so nice. So this line 116, what it's doing is saying, hold off on doing this until it's done, until the completion op is finished. But once the completion op is done, like this remove value, do you guys remember what this said? It says, removes the given key and its associated value from the dictionary. So it's clearing out the dictionary from that operation. We don't need to allocate memory to that particular operation anymore because it's done. So this is just a good memory handle thing. Cool. So what we've done here is we've made two operations to work in tandem with our fetch op. So our fetch op is going to do the network task of pulling down data from the API. The cache op is going to save that data in the cache and give every single data, I don't know what the word is for it, just every single instance of data, both a key. So it's going to have a key for it so that it can match up with the value. And there's another operation that is actually doing like loading the image, like putting the image into the cell. We're missing one critical aspect. This is all happening on a background thread. We need to put it where?
On the main thread.
Yes, because it's a UI change. It needs to happen on the main thread. It's not going to show anything unless it's on the main thread. So what we're going to do is, and we actually forgot to do something here too. We want to put photo fetch queue and add another operation. What do we need to add? What else do we need to add to the fetch queue? Because this is just a timing issue. This isn't actually adding it to the background thread. These are just saying like, hey, these operations can't happen until fetch op is done. But they're not actually in the, like, they're not in line to do anything yet.
Need to add the cache op.
Yep. So we're going to add cache op. And then we're going to do something a little bit differently. And this is why there's beauty in making this completion op. Instead of adding photo fetch queue, like adding the operation onto the main thread. What we're going to do now is we're going to go into operation queue. And we probably might even be able to do dispatch queue. An operation queue executes its queued operation objects based on their priority and readiness. After being added to an operation queue, an operation remains in its queue until it reports that it's finished with its task. You can't directly remove an operation from a queue after it has been added. So this is how we're going to kind of assimilate all these background things to happen, to actually like occur together. So operation queue has a property called main. So it says returns the operation queue associated with the main thread. So this is how we're going to tie it onto the main thread. So operation queue.main, and then add operation. Now this is going to be kind of tricky to think about. But which operation do I want to add here?
Photo effects queue.
The completion op.
Yes, Alex, tell me why it's completion.
Because that's where we're changing the image.
Yeah. And if you look here, so like completion op can't happen until fetch op has happened. So fetch op is going to find and pull down that data from the API. Cache op, I mean, is a nice thing to have. It's going to cache that image for us. It's going to be super helpful, particularly in lines 100 through 104. But we really don't want to have anything update on the main thread until completion op has finished. So the beauty of setting it up this way is like, hey, we can do things back on the main queue after completion op is done, or when completion op is like ready to fire, ready to go. So if we did fetch op here, we maybe can't guarantee that completion op is going to be finished in time. But if I add completion op onto the main thread, it's going to make sure that all of this happens first, and then this can happen, and then we'll be good to go, because this is our real like UI change that we're making on the main thread. So does that make sense to you guys? It's kind of a tricky concept to think about. The whole timing aspect is difficult.
You know, the thing that kind of blew my mind is in I think it's 109. So when you're doing the let cache op equals, the thing that gets me is the if let data. So the first thing in my mind is, well, where the hell did that come from? You know what I mean? Like, how does it know anything about data?
So we declared fetch op up here.
Or even access to the fetch op. Like, can it just reach over there in a different thread and say, oh, I want this fetch ops image data? I guess my curiosity or my confusion is it's not like this is just going to happen once and there's only going to be one fetch op, you know, waiting in queue or running. So how does it know which fetch op it's tied to?
That is the beauty of operation queue. I don't have all the answers for you for it, but that's the cool part, especially because this concurrent operations kind of boilerplate code that we have, it's going to take care of all that stuff for you. So like you could totally read in on operation and figure out how this works, because it's got all these aspects that we use to block operation queue. But I mean, that's the tricky part of concurrency, is that you kind of have to hands off, just let it do its thing. And somehow, as long as you've tied everything together, especially with lines 127 through 132, you kind of just have to let it do its thing after you've set it up to go a certain way. And so you guys saw some of like the thread sanitizing stuff and like slowing down your network. Those are great ways to kind of test and see how your concurrency is filing away. But that's also the hard part, is like there's really no good way to know how this is happening under the hood. Because even though you can set breakpoints and things, this is on a whole nother like galactic level of code that it's under the hood. It's hard. So I don't have a good answer for you, Josh, other than I'm glad that someone's gone to the work of creating the operation class, like the type of operation, because it saved us a lot of grief.
132, is that the line that puts it back on the main? thread.
Yeah, so this
That's-
operation queue is still, so when we came up here, I told you guys on line 17, this is not a serial queue. This is still a background queue. But there is sort of like think of it like train tracks where you have two trains converging on a point. There's kind of like those switches that will line up the train tracks so that one can come in. This main aspect, it does that job for us. It kind of assimilates the background thread to come into where the main thread is working. So this is a serial queue, this is a background queue, and then it has a property that kind of lets it segue into the main queue.
Okay, got it.
Concurrency is tricky, you guys, especially like walking through this with you. I'm realizing how much I don't know, and it's difficult, but you guys are doing a really, really good job with it.
I feel like the sync and not like, but it's like, I feel like the queues take away a lot of the headache for the sync and async, if that makes sense, even though it's running on, I don't know how to explain that in my head.
Well, like a majority of the
It's in my mind.
you guys are going to do async to kind of, because things don't need to run before other things generally. Like you're going to pull information and get information as it comes, but there are certain aspects that you're going to wait until they actually show up. So like a great example of this is like, we're not going to pull out a value that's cached unless we have it. So like this can run asynchronously because it's like, let's just get it whenever we can. But this one has to run synchronously because it's like, hey, you can't run this function if there's nothing to find. It's dependent on another operation to work. It's dependent on this queue's values to be working. So yeah, you're right, Alex. There are like a lot of under the hood things that are happening that are going to save you guys some headaches. I can only imagine like what people had to do 10, 15 years ago before all of these like generic types were implemented, and they're so helpful. So anyways,
I would not be.
neither would I.
Okay.
Neither would I. So the last thing on this, this is the very last step. Actually, we need to implement cancellation, but we're pretty much done. It says when you finish creating and starting the operations for a cell, add the fetch operation to your dictionary. This way, you can retrieve it later to cancel it if need be. So this is also somewhat of a it's more of an optional step. But what we're going to do is we're just going to say our operations have that dictionary value. So we can come in, and I mean, it won't auto-populate for me, but I can look up the specific operation of each photo references ID and attribute it to the fetch op it's occurring on. So this particular fetch op, I can line up with the cell it's trying to pull up, the actual like photo reference that it's trying to pull up, if it ends up canceling. I mean, if everything goes well, it should remove it, right? Because we made this remove value in the completion block. But if for whatever reason it cancels, this will let us pull it up and reference it later. And I'll show you it when we implement cancel in just a sec. I'm going to do one commit really quick. So I'm just going to say configure load image method. So this is like the concurrent powerful way to change this load image. We wouldn't, instead of running a URL session directly in here, the work that we did tonight was we moved it all to a background thread, and it will work so much faster because we're taking advantage of multiple background threads. And then it makes sure that we got data and loaded it in to be a UI image before it actually came back to the main thread right here. So the last thing, and you guys will see this when I run it here, actually. We'll run it. Everything should come up clean. The problem is that things that load are going to stay. And in a lot of apps, you're going to want this, right? Like on Instagram, if I scroll way, way down and then I want to go back to the top of my feed, it's going to be kind of a pain if I hit the home button and then the top image has stopped loading. So you won't always want to implement cancellation. But if you guys look at this, like I went a little fast. Our images are actually loading a lot faster. My computer's just running slow because of Zoom, but like our images are loading a lot faster than they were before. Like much, much faster. I mean, once it gets to that point, like there's so many background threads firing and they're converging on the main thread right as we're speaking, and all these images are loading. Now the main issue is I'm taking up a ton of, not a ton, but I'm taking a good amount of memory up to load all these. And then if I scroll up, like they're still there. So that's not always the best case, especially like we've got so many images loading here that it's probably not great. So I'll show you guys how to implement cancellation. It's not hard. What we're gonna do is we're gonna come to our collection view data source, and it actually already conforms to the protocol that we need, UI collection view data source, and the collection view delegate flow layout. So there's a really easy function that you guys can implement here. Sorry, I have to slide it over so I can look at it really quick. So what we're gonna do, we're gonna just make some space. Implement cancellation. So that what's gonna happen now is that after the view, like after you keep scrolling, the things that you've already passed are gonna stop being available to see. They'll go away so that we don't have to like keep allocating memory for those. And then you can scroll back up and they'll load again because it's interactive and dynamic in that way. So there's a really cool method and it's called didEndDisplaying. So let me see if I can find it right here. Where's didEndDisplaying? Maybe I have to type collection view for it. Let's see. didEndDisplaying. I think this is the right one. Size for item map. Yes, this is the right one. It's that very first one. So hopefully you guys got that. For item map. Okay, so it's collection view, didEndDisplaying cell for item at index path. It looks a little different than the other one, but I'm pretty sure that's right. Yeah, we're good. Okay, so then what we're gonna do is we're going to give it a photo reference. It comes from, and we've been using it this whole time. It's the same line of code. It's your index path guardlet photo. It's guardlet Pokemon equal Pokemons.indexpath.row. That's exactly what this is. Like we've used this 100,000 times in your other past code. So we're saying at that specific index path and the item that's at it, we need to cancel. So this is how we're going to implement this cancel method. So what's happening here is what we do is we go back to, and this is where it's going to come in handy that we added this operations thing. It's going to come back to be useful. We're just going to say operations and then photo reference .id. Because if it canceled down here, we saved it. We saved it into our operations. And then what we do is, I'm trying to remember exactly, it's optional, I think. Yeah. So all of our operations have the cancel property attributed to them. Let me scroll up so you can see the type. So these are all a dictionary, but every operation has that .cancel property, and it will just finish running the operation on the background thread, and it will just stop working. So oh, sorry, I keep scrolling around because I'm losing track of my code. This cancel is saying, okay, find the operation that's occurring for this specific operation reference, like the photo reference. Sorry, I'm mixing up my words here. For every integer that's attributed to the photo, cancel the operation that's happening with that integer. Another big reason to love identifiers. So it's just saying, hey, if photo 1 is no longer on the view, cancel it. That's what this cool data source method does for us. So now when I run this, if we scroll off page, we should be able to scroll back up and we'll have those like moon placeholders, and then it will reload the image for us. So it'll be like kind of a dynamic reload happening. I'm going to be so sad if it doesn't do it because I'm going to be sad is what I mean. All right, so let's scroll through. Let's let them load up a little bit. So now these are the only images that should be loaded into view. Our did end displaying should do the work of canceling. Yes, did you guys see that? I think you only saw like one of them because our background thread's actually firing pretty fast. But if I scroll down a bit and we stop, we should see a couple of moons up at the top, which just means, for one, our background thread is fetching them pretty quickly when they come into view. But if I scroll up enough, yes. Did you guys see that? Did everyone see that?
I'm lagging a ton, so it's like almost like a pictogram.
Oh,
Like,
sorry, Will.
sorry.
Sorry, but if you see it, I scrolled too fast. There we go. So like moons are loading because they weren't on view. If we simulated that slow network connection, you guys would see this really, really well, but I don't want to go to the work of doing that because it's silly. But if I scroll up far enough, I mean, the images are loading pretty quick, but at least that when they were off display, they weren't being loaded anymore. Our main thread was like, hey, don't allocate memory to these anymore. You can put them back to their placeholder image and not have to keep making that network call or like loading the image from data. Woo! Okay, you guys, we did a lot tonight. What questions do you have for me?
Can you do like a you kind of did it just now, but like a bird's eye kind of run through with like how the cache is working with like concurrency and like when you're switching between the main and the background type stuff? Maybe just like a very brief flyover on the code.
Cool. And that's another reason why things were loading so quickly is like a majority of these images now, like they're cached. Now that I've been on working through the app for enough, I mean, we're getting down here where these things haven't been loaded yet. But up at the top, a majority of these images have been cached. So that's why they're still loading and appearing, which is super nice. Bye, Alex. Thanks for coming. See you tomorrow. All right. So a bird's eye view. Sorry, I was getting there. So the cache is just helpful in storage, in just kind of having like a reference to pull from, especially when you don't want to make a network call every single time. So that'll just limit the amount of network calls that are being fired, which you can imagine is smart and dynamic. If your user doesn't have a great internet connection, we'd rather have things just load one time from like an internet connection rather than multiple times. So what we did, I think cache was the first thing that we did, right? So we made a cache and it was just a dictionary. And we just said, we can save things as long as they have some sort of key and then a value that we want to keep saved to like pull from. And as you can imagine, data is a lot easier to save than a UI image. It's like a UI image would be significantly larger in size. So like the memory allocation would be a lot more. And then we made a serial queue where this can be saved. So like we got this on the serial queue to be saving those cached values. And if we took out the cache, like things would work. I don't know how much the speed difference would change, but all of this would still work. And I think the loading would still be pretty smooth. The cache just helps load images, and like down here, we've never even gotten this far yet. So it took a little bit of time to load these. These are kind of cool. Like these are taking a bit to load. They might not even load at all. But the cache is great because then I can scroll back up to the top and these images are going to fly back in quick because I don't need, for this particular cell, I don't need to make a network call because it's already been cached. So if I commented out this code, it would take a little bit longer. So the cache is just awesome for that. So what we did is we used this boilerplate concurrent operation code it's really helpful because it just keeps track of our operations to vary between these states. We didn't really talk about asynchronous today at all, but it's going to change depending on the value that we've attributed, depending on if it's ready, if it's executing, or if it's finished. So with that boilerplate code, we made a custom operation. And our custom operation is going to work on a background thread and do specific things that we want it to do. So in this particular case, we wanted it to make a network call, find a particular photo, and get the data from that photo so that we could turn it into URL, not a URL, I'm sorry. We could turn data into a UI image. So that's what this start is doing here. So start is going to change that state to is executing, which under the hood, operation is looking for that in order to fire. It needs to know that the state is dot executing in order for this operation to start to work. We queued it up too so that if it ends up canceling, we just return out of the function. And we made it so that it won't turn into that dot is finished state until it's done. Because we wouldn't want like partial image URL or none at all. We want to make sure that we get it and then we can turn to this is finished state, because then the operation can stop firing then. We made a cancel, but I'll talk about that here in a second. Now this is all living within a class. So this isn't like doing anything yet until we implement it into our collection view controller. So instead of just running a network call in the load image, what we did instead is we declared our fetch photo op. And then because we have that now, we can put it onto the main queue. So it can do it on the background via the configuration we gave it here, right? So here's the URL session, here's all the information. But in the photos collection view controller, I'm hopping around everywhere, I'm so sorry, but we declared it as type operation queue, which is not a serial queue, it's not a main queue. This is a background queue. So the main difference that happened here from the very start of the project, the start of the project was not doing this on a background queue. Well, it was doing it on a background queue, but it was doing it when it wanted to. We kind of took control and put it on specific background queues to make sure it got done. And because it did it that way, it was a lot faster. We made our fetch op, and then we made some block operations to kind of work underneath that, right? So it's like, go and find the image data with this photo fetch op. And then if you get it, let's cache it into our cache. And also if you get it, let's go ahead and load it as a UI image into the cell. And then after that, there's all these cool properties. So like operations can be dependent on another operation. So I could make 30 operations and have them all wait until fetch op is done if I wanted to. In this particular instance, we only made 2 because like cache op is not going to do a good job of what we need it to unless it actually has data from the fetch operation. And completion is not going to be able to do its job unless we also have data from the fetch operation. Because if you look, both of these require that we get data, from image data right there. And then we used operation q.main to put that back on the main thread. So it said run all these things, fire all these operations, and then once it's done and good, put it back on the main queue so that we can update UI without slowing down the user's interaction. So this is like heavy stuff, and I wish we would have done it in a guided project rather than this late at night for you guys. Probably doing it really for the first time. But did that help, William?
Yeah, it helped. I think because he went over a ton on sync async, I'm trying to wrap that, in with all of this too, and trying to see what the difference is. And so that kind of threw me off a bit, but this makes a little bit more sense.
Yeah. And like going forward with operations, you're going to, like, if you think about it, these are sync operations right here. So like we, how do I say? This cache op is synchronous with fetch op. And completion op is also synchronous with, in a roundabout way, fetch op as well, right? Because they're dependent on each other. So this is similar to saying, and I'm pretty sure if I tap this, it'll actually pull up some information on it. No, it didn't say anything, but these codes are synchronous. So like you can think of them just in a roundabout way of being sync. And fetch op is an async operation. It can do it whenever it is ready and needs to. So don't let those confuse you. They're still wrapped into these concepts. They're just, we're not typing out sync, async like we were in previous apps.
Yeah, I think it's making a lot more sense now. So like async is like, from what Johnny said, was like the background stuff, right? And then sync is kind of like the foreground. And all we're doing now is kind of like doing that, but in a different way, in dividing up the work.
Yeah, there is a different way. Yeah, this is just like a different route of taking it. I just like to think of it as like sync needs to sync with something else. Async can do it whenever it needs to, whenever it's available to. So up until now, we've been doing dispatch queue.main.async because we've really only had like one operation to put on the main thread, but now we're kind of running several operations, and so we need to use async and sync in tandem in a couple of ways. So,
Well, and on a background thread to get it off the main.
yeah, it's like Inception, right? Like we're letting things happen in a certain order on the background thread so that they can happen in a certain order on the main thread.
But when you say Inception, are you referring to the movie where they go three dreams deep?
Yeah. It's like layered. Yeah.
It is weird.
Yeah, I'll tell you this app, even though I'm pretty sure I didn't finish the cancel part, but I just get a white screen.
You what? Sorry.
I had that problem all day. I just ran it. I run it probably 15 minutes ago. It hadn't done crap.
Really?
Yeah, and those playgrounds today, the same problem Mark was having. He told us in stand up, it's like I'd try to run one of them and getting errors, like today, like getting errors that the instructor didn't have, or I'd run it and it would either take forever to run or never run, and I'd have to restart. So
that's the gambit with IDEs. So that's what we call like Xcode is our IDE.
yeah.
And like Android developers use Android Studio, but like none of them are perfect, sadly. I wish they were, but we'll always have our beefs with Xcode, even though it gets better and better. It just will always struggle.
Hey, this is better than a green monochrome screen connected to a microcomputer.
This is better than holes punched into a piece of paper that you have to feed.
Oh, yeah, exactly. You got where I'm going here. Yeah, you just.
We're blessed. We're blessed. There's still some like things to hammer out, but we're in a much better place than developers 50 years ago, which is awesome. So
I mean, I remember having to run a linker. You had to run a linker, then a compiler.
Yeah,
you had to link in all the includes, and the already compiled libraries,
Ugh.
Yeah,
It sounds miserable.
IDEs are awesome, but yeah, they can be buggy.
Yeah, they'll be buggy. So my good fix for whenever those things happen is clean your build folder. So like you can come up here to product and then clean your build folder. That's a great fix. And then just like quitting Xcode, you'd be surprised to find how many times it fixes your issue just by quitting the app and then coming back into it. It's weird. So
yeah, like was that today or yesterday where this guy copied the code and the playground didn't run, and it was like totally just like the same code?
Yeah.
I did the same thing, and my machine did the same thing, and it would not run.
It's weird. And I don't love playgrounds for that very reason. I mean, once you add more than like 50 lines of code into a playground, it just starts to struggle. So I don't know. But anyways, do you guys have any more questions about this? Do you feel better about all the content now?
Definitely, yeah.
Okay.
Appreciate it.
Cool.
Yeah.
Well, thanks for coming on, guys. This was a pretty beefy, heavy thing to tackle, and I'm glad I got to go through it again because I feel like I've learned that much more by working through it with you guys. So good work. I will zip it up and post the video.
I'm feeling like tomorrow is probably a lost cause, but I think going through this project with you has given me a bit of hope.
You're guys awesome.
First time I've ever gone into a Friday or gone into a sprint just kind of going,
oh no.
I don't know how this is going to go.
So tomorrow, and I'll tell you guys this too, tomorrow's API is one that you've already used. Well, if you come to after hours, you've used it with me at least one time.
Yeah.
So there's that. It's going to be significantly easier than this API that's this NASA one, because look at how many, they've got 4 model objects working off each other here, which is a mess. Tomorrow, it's going to be a lot more simple. So, and tomorrow's not going to be a collection view. It's going to be a table view, which I love table views.
Table views seem to be infinitely easier to deal with.
Yeah, I have a beef with collection views. I'm not a fan, but it's
Yeah.
not to say that they're not powerful. I just don't.
I ran into issues with the collection because I realized you couldn't add a delete function very easily. It's like you have to do a whole bunch of things.
Yeah, there's no swipe to delete, which is a pain. So anyways, well, you guys are awesome. Let me know if I can do anything else for you. I'm going to close it out and post the solution code if you need it. I'm pretty sure you guys are probably at a working point. Tips for tomorrow: rely on this project when you build your block operations in your operation queue. And just remember what you learned from like networking, because you're going to have to network tomorrow a little bit. It's not going to be nearly as hard. You won't need an API key. Your model object will be pretty simple. So you guys are going to do fine. I'm not worried about you tomorrow. So.
All right. Thanks, Mitch.
You bet, guys. Message me if you need anything else, but I will plan on seeing you, chatting with you tomorrow maybe, but definitely seeing you guys next week.
All right.
Thanks, guys. Have a good night.